We've said the words Spring, Spring Boot, and Spring Framework a lot so far. What is Spring, and why do people think it's so powerful? At its core, Spring is an implementation of inversion of control, a popular enterprise design pattern. What it means is this. Most applications can be thought of as a collection of code components, some of which are business logic, meaning they contain the high-level steps of our application's features, and some of which are persistent objects with resources and state that have to be initialized and maintained carefully. In simple application programming, you might write all of the logic initializing these components and connecting them manually. But as those components become more complex and numerous, it becomes harder and more error-prone to do so. Does the database need to be initialized before the file cache? Where should you start the thread pool and the request listener? And how are you going to rewrite your code connecting everything if something changes, like switching to a different database? Inversion of control is a software design pattern where you tell a framework what components need to exist, how to create them, and which components are needed by other components to function. Then, when you run the application, your IOC framework of choice automatically initializes your components and connects them, procedurally determining the best order and organization in which to do so. That means you can focus on designing robust, powerful components and leave the connections between them to the framework, and changes to your design will be automatically factored in to each deployment. Spring is our framework of choice for inversion of control, and it's provided to us in the form of dependency injection. What that means is that when we define a component, we also define its dependencies, other components that it needs to perform its function. Then, when we run our app, Spring ensures that all components are created in a compatible order and injects dependencies in the components that declared them. Dependencies can be of any value, including everything from strings and numbers to database drivers and request handlers. And Spring can recognize dependencies by Java type, component name, and configuration property. That means that Spring is incredibly flexible and powerful, and we can define any number of possibly variable components as dependencies to be injected throughout our app. We can define constants, like service URLs and driver class names, as dependencies, as well as the service classes that use them. We can define entire layers of business logic methods as components that depend on resources like database drivers that can be changed with a simple config file edit, which means that we can focus our development efforts on what matters, features and business logic. Ultimately, the use of an IOC framework like Spring allows for structured application development, where the focus is on dividing the app's requirements into single-purpose components that can be combined to implement features. It may be confusing at first, but once you get used to it, it's hard to imagine building an application any other way.